is what I want. Ooh. All right, there's a blinking red dot, which I believe means we are now being videotaped. All right, ready to go. No response, blank stares. Hang on, I gotta get all your faces. I gotta make the grid bigger so I can see all your faces. It really is, I'm not making this up. It really is challenging. When I stand in front of a class of human beings, I can read faces and see when people, you really do have a physical facial reaction when you don't understand something. Through these cameras, it's really hard to read your face and say, you know, okay, they don't get it. So you really got to speak up. This stuff is not difficult, but if your calculator runs into issues, you got to speak up. Okay, so here we go. What you see is a hypothetical set of quiz scores for 5 students, and they're in list 2. Now, you should have typed these in your calculator earlier when we did scatter plots. So L1 and L2 were in there. I'll be quiet for a second and let you type in L3. L3 is going to be 00011. The way that you get to this stuff is to get to this screen here, you press, see if I can remember, stat, and then you go under the edit. Okay, and if I put a box around something, it's a button. Stat is down and to the left. It's directly left of the arrow keys on your calculator. And then edit is the first option. And then just use your arrow keys to get over to L3. And then you type in 00011. Okay, so L1, we're going to delay a little bit. We're not going to use that quite yet. L2 is the set of quiz scores that we're looking at. So somebody gave a quiz, and the scores on that quiz were 2, 4, 6, 8, and 15. Okay. Now, these are a famous set of numbers because they demonstrate some stat topics that make the calculations very easy. So obviously they're fake. But the first thing that we're going to do is we would like to calculate the mean. So using our friendly raccoon frying a fish. New is when you press stat and this time go over to calculate, you're going to want to calculate one variable stats, which is the first option. Now, this screen here is going to look different for different people. So you might not all have this kind of screen. Okay, my old school TI-83 does not look like that. But somehow, when you get one variable stats, you need to type in actually just pretty much one thing. You need to get your calculator recognize that you're trying to find the average for list L2. And again, you cannot type alpha L2. You need to go above the number 2. Second 2 gives you L2. Frequency list doesn't appear on everybody's screen, but if it shows up on yours, you can leave it blank. And then you arrow down to calculate, press enter. And then you get a screen of numbers that has this little arrow. The fish is pointing to the little arrow on the lower left corner, which means, hey, there's more output on the next screen. So if you press the down arrow key, you get this output here. So I'm going to pause right there. That's kind of a key step, probably the most important thing for the calculator on day 1, chapter 4. Those of you following along with your calculator, did it work on your calculator? Were you able to follow those steps? Can you get the X bar equals 7 screen to show up? Give me a thumbs up.
Wait, how do I switch my list from L1 to L2?
You tell it second 2 will change L1 into L2. So if you look at the keypad on your calculator, 1, 2, 3, 4, 5, 6, 7, 8, 9, above those are L1, L2, L3, L4, L5, L6. Anybody else have a calculator question? Are you all getting it to work? Going once, going twice. Okay, so what does this stuff mean? Well, here we go. Here come the notes. Switch to blue. All right, so I'm going to make 3 columns. The mean is the first topic. The median is the second topic. And a proportion is the third topic. Okay, the symbol for the mean is X bar or mu. And way back in chapter 1, we talked about sometimes you're collecting information from a sample and sometimes you're collecting information from a population. That was important back then, and it's so important now that we have 2 different symbols. X bar is the sample mean, and all Greek letters represent population numbers. So if we were taking a poll for the state of Illinois, who somebody was going to vote for governor, if I was able to ask every single eligible voter in the state of Illinois, whatever summary number I get, I would label that with a Greek letter. Okay, since that's realistically not feasible, and it's also would be prohibitively expensive. We take polls, which are samples, and then any information that we get from a poll or a sample gets labeled with a what's called an Arabic number. Those are the numbers that we naturally use, like X's and X's, Y's, Z's, just plain old regular letters. Okay, so that's that. You are going to be responsible for knowing a couple formulas, and mean is one of them. X bar is calculated by doing the sum from I equals 1 to n of x sub I, which in shorthand notation is just sum of the x's over n. Whoops, I forgot something on the first one. So put that divided by n there. Okay, so the official formula is the one in the middle. The shorthand notation is the one on the right. And how the usual works? And I'm going to put this in a different color. If you see me write this down on your paper, these are the 3 steps you have to show. FSA stands for formula, substitution, answer. You do not need to do any of the grinding through calculations. You just need to write down the formula. You need to substitute in numbers. And then in the end, you have your calculator spit out the answer and you copy the answer on your paper. So that looks like this. The sum of the quiz scores in L2 would be 2 plus 4 plus, I'm getting tired, so I'm going to go plus dot 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 plus 15, all divided by, how many quiz scores were there? 1, 2, 3, 4, 5. 5, and I'm writing in the wrong color. Thanks for telling me. Come on, I'm trying to color coordinate things for you guys. Okay, and when I do that calculation on my calculator, the mean, which is right here in the calculator output, equals 7. The average score on that quiz was a 7. Okay, and it doesn't hurt in the end to actually bring down the symbol and say X bar equals 7. And then of course we always highlight because we can. So there it is. Okay, now the danger is your calculator can do these calculations for you. You just, sometimes you're going to be given a list of numbers. You're going to say, all right, well, I'll find out the average, type it in my calculator, write down 7. That's not quite good enough. The way they grade is, because there's a couple formulas that are very similar, the way they grade and make sure that you're doing the right process is formula, substitution, answers. So I have the formula. I substituted a few of the numbers and I wrote down the answer. Okay, so a couple properties of the mean is there. Let's how much space do we got left? Oh, good, just about right. The mean uses all data. Okay, and the mean is non-resistant. And I will explain what non-resistant is after we study the median. All right, mean is done. You know what the average is. Sorry, I need to get a cough drop. I don't want to keep coughing all over the lesson. You know what the average is. You've seen average before. I think you all know how to calculate that. The idea is that we're going to use this formula, a structure of this formula in a couple different places when it gets a little bit more challenging. I can move on, yes? Okay, median has no symbol, so you got to write the word. Okay, sorry, I wish it did. Some books use a capital N, but that's not universal because other books use capital M for the maximum of the data set. It is defined as the middle number in an ordered list. And you need to highlight, oh geez. You need to highlight the word ordered. That's important, okay? If your numbers are not given to you in order, then you gotta put them in order before you can find the median. Okay. So let's say n is odd, and we have 2, 4, 6, 8, 15. Now I happen to give you quiz scores in order, but okay. The median is going to be the middle number, which is 6. Okay, there's no formula. You just put the numbers in order and you write down what the middle number is. If n is even, it's a little bit more of a challenge. Okay, let's say 2, 4, 6, 8, 10, and 15. So I added in, a new kid got added, and that new kid got a 10 on the quiz, second highest score in the class. How do we find the middle number if there's an even? You take the middle 2 and you find the mean of the middle 2. So the average of 6 and 8 is obviously 7. So the median is 7. And that comes from averaging the middle 2. I'm pretty sure you've seen median before, so I don't think that this is rocket scientist or anything, anything close to calculus. The median situation uses only the middle number. Okay. And the median is resistant. Okay. So before we go on, I'm going to say that non-resistant and resistant will be demonstrated down here. The whole reason for this example that's coming up in a second is to discuss what's happening with resistant and non-resistant. So we'll get to that in a second. Everybody happy with median definitions? Any questions? Very straightforward. Borderline easy for now. The evil teacher laugh. Okay, pause while you catch up. Coffee break if you need it. I'm happy that at least a couple of people have their cameras on because I can tell when they're writing, and that tells me it's another visual cue that I don't get when you're not in the room with me. I can tell when people are still writing, and so now they could be doing homework for a different class or coloring, but okay. So does your calculator show you the median? Yes. The mean, when you do one variable stats, the mean is the first thing that shows up. In order to see the median, you got to do that scrolling down with the arrow button, and the median is right there on the second screen. So that agrees with, excuse me, that agrees with what we found when I did the median right. Where's my, okay, I hit the wrong button, and I don't know why the voice needs to sound so depressed, but the median on the calculator, which the fish is pointing to, agrees with the median that I found by hand. Obviously, with a bigger data set, it would really be annoying to put the numbers in order and then find out where the middle number is. So, all right, ready for the last topic? Yes, okay. So proportions are not used in quantitative data. Proportions are used to summarize the center of categorical data. And I'm going to go back and fill in a couple words with the lovely purple. Proportions are used for categorical, whereas median is for quantitative and mean is for quantitative. Okay, so what do I mean by categorical? Let's say we took our quiz scores and we decided that, what did I say in my notes? Let's say passing is greater than or equal to 7.5. Okay, so in the calculator screen, I took anybody that got a passing grade. Oops, that's not passing. Anybody that got a passing grade got a 1, and anybody that got a failing grade got a 0. So it is sometimes common to code categorical variables. In this case, I called failing 0 and passing 1. And if I wanted to know what proportion of the students, if I wanted to summarize the class, I want to know what proportion of the students passed, then the proportion, which is symbolized with a P, equals 2 out of the 5 passed, which is 0.4. So that's a summary number, okay? Actually, I need to cheat for 1 second. Here's where things get a little bit annoying and confusing. The symbols for proportion are not universal, and I can't remember which symbol our book uses. I've taught out of 3 different stat books in the past couple of years, so give me a second to look it up. Okay, good. So they stick with the thing that makes sense. It's the AP formula sheet that's a little bit backwards, but that's okay. We'll figure it out. All right, so when we had just our 5 kids, the sample proportion was a P. If you want to know the population proportion, that's a pi. And that sticks with the system where Greek letters are used for summarizing population numbers and Arabic letters are used for summarizing from samples. So in my sample of 5 students, 2 of the 5 passed for 40%. If I was going to take everyone who ever took this quiz or test in the world, the entire population, then I would use pi to represent that. The reason why some books don't use pi is that too many people are attached to pi equaling 3.14159. So when they go to take a stats test, they just automatically write down 3.14 for pi. So I get it, but also it doesn't make sense. You'd think that people would be able to adjust. All right, checking my notes. Yeah, I'm done with the notes for section 1. So we're going to go through an example right below to demonstrate the difference between resistant and non-resistant. And then we're going to switch gears into something that's a little bit more, I think, interesting. Questions? Going once? Going twice? Okay, so here is a real picture, not made up. There's one tiny error, which I unfortunately did not have time to go into and fix. This is not for the 6-county region. This is for the entire state of Illinois. But what you're looking at is a picture of how much high school districts spend per student to educate their students, okay? And this is only high schools. So we took every high school district in the state. They had to report this to the state, how much they spend per student to educate the kids. And then this is a distribution. So since this is a histogram, I could have put this on an earlier tester quiz and said, please summarize this. And you would have gone through center, shape, spread, and unusual. Yes? Okay. The thing we're focusing in on today is center. What is the typical amount that a high school in the state of Illinois spends on students? And let me qualify a couple things. High school districts do not include like Barrington, because Barrington is unit district. So while Barrington has a lot of money, they wouldn't show up in this plot because they're a unit district and they only do their calculations for both high schools and elementary schools combined. And also the city of Chicago is a unit district, so they're not in here either. This is only districts that are exclusively high schools, like ours, like 211. The main district, I think Niles is a high school district. So anyway, off to the right, you see summary numbers, okay? A lot of times they can give you statistical output. There's, you know, they usually make it pretty readable. They won't endorse a single one. They don't want to get in the business of endorsing statistical software. But I'm hoping that you can see that median and mean obviously are very easy to find. If they're both measures of center, why are they off by what, about 650 students? Okay, that seems, sorry, not 650 students, $650. So we're talking about how much a school spends on the student. If I'm going to try and measure the center, why is there a $650 gap between those two? Well, because when we talk about shape, the shape of that distribution is skewed right. If I'm going to draw a summary curve on this thing, it's going to go like this. And since the tail is often to the right, it's called skewed right. So what does that mean? I'm going to plot as best I can the mean and the median. So let's put, let's color coordinate things. We'll put mean in a lovely purple. And we'll put median in hopefully a contrasting green. Some point I should have asked if people are colorblind. I try not to use colors too often. Here, you know what we'll do? We'll also make them symbols. So mean will be a circle that's purple and median will be a square that's green. That way, if you are purple-green colorblind, you're not at a disadvantage. So switching back to purple, let's put a little purple dot where the average expenditures for a student is 6571. So 4,000 to 8,000. This is going to be 6,000. That's not a pen. This is going to be 6,000. If I'm looking for what, 6,500? If I'm looking for 6,500, then 7,000 would be 7,000 would be right here, and 6,500 is going to be roughly right there. So right about there is where I have the mean, which I said was going to be what symbol? Purple dot. On average, a high school district spends $6,500 and $6,571 to educate student per year. Okay, what's the median? 5912. So the median, which we said was going to be a green box, 6,059.12 is going to be right about here. So is that a big gap? Is there a big gap between the two of those? Let's put them on the, actually on the axis here. I think that is, okay. What did I say, 550, what's the difference between those two? Roughly $650, okay. Why did that gap happen? Well, it's related to shape. Because the distribution is skewed right, and I'm going to draw that skewed right back on there, okay? And because the mean is non-resistant, the mean gets dragged towards the extreme values, okay? These would be called extreme, or towards the tail values. And notice I didn't say outliers, okay? Outliers can have a very specific mathematical definition. The mean gets dragged towards the tail or towards the extreme values that you see in a distribution. The median is resistant. So despite the fact there are extreme values, it does not get dragged toward the extreme values. So if you pay attention to sports at all, it used to be that they would report the average salary of a baseball player or the average salary of a football player in the newspaper. And they say, look how much more these athletes make than the rest of the people. Now they've switched to reporting the median. Okay, because there have been a couple extremely high values in salaries for baseball and football players, the average gets very much distorted and dragged towards the tail. So if you're going to talk about how much a typical football or baseball player makes, it's better to report the median. And the reason why that it's better to report the typical median value and why is resistant better, because that tells you exactly where half the people are. If you report the median baseball player's salary, you know that that number, half the players make more than that, and half the players make less than that. That's not true with the mean or the average, okay? If you report the average or the mean value, you could have a very small subset making above that and the vast majority of the players making below that, okay? That happens with salaries in like banks, for example. The CEOs make so much and the high-end 2 or 3 make so much money that it drags the average very high. Almost 95% of the company makes less than the average amount, but because of those couple people, only 5% make above the average amount. Okay, so have we beat that into the ground? Does everything, all those vocabulary words, all that stuff make sense? Should not be a very mathematically intense topic. I think it's pretty straightforward, but there's a couple things you got to pay attention to, and I'm going to highlight this one more time. People can't stand losing points for easy things, okay? That FSA, formula substitution answer, that's how we grade. If you're asked to specifically calculate the mean, you write down the formula, you show a couple substitutions, and then use your calculator to find the answer. You do not have to calculate means by hand. Okay, it's just way too time consuming. Waste of time. All right, let me check my notes, and I think we are going to be done with part 1. Yes, we are done with part 1. And let me check time. We've got 35 minutes left. I'm going to stop recording for a few seconds so that we can talk about the people that are absent.